Now, in this video, we are going to take up one more problem on projections of lines. How to analyze this problem in 3 dimension and how to draw it by using the manual sketching, that is by using the sketchbook. The point capital B of a line AB is on horizontal plane. So that means he has given the locus of B in the front view. The top view of the line makes an angle of 30 degree with XY line. So that means he has given the beta inclination being 80 mm. He has given the top view line. The point A is on the vertical plane. Is on VP means what? It is on HP. And 40 mm above horizontal plane. So it becomes on VP. Draw the top and front views of the line and obtain the true length of the line and also find the inclination of the line with two planes. So this is the problem which is given. So how to solve this problem? By taking consideration of the 3D. We will try to analyze this by using 3 dimension. So what he says, a point is A is on vertical plane and 40 mm above HP. So as we say, point A is on HP. So obviously that image will going to be seen on the vertical plane. So that is on A. Then it is above HP. So from X above HP is seen in VP. So you take the distance from XY line to a 40 mm and draw a horizontal line. And you mark this point as A dash and A, and here it is capital A and here it is capital A. So then the top view of the line is inclined at 30 degrees to VP and it is 80 mm. So he has given the apparent inclination and the apparent length. Where you will be able to get the top view. The top view can be get on horizontal plane. So from this point you measure an angle of 30 degrees and draw a line inclined at 80 mm. Inclined at 30 degrees to 80 mm. So now you have the top view line which is AB. Since you know the top view of the B, so you are going to get the locus of B in the top view. Then also he says the point B, one end of the line to the point B is on the horizontal plane. Is on the horizontal plane means where? It is on VP. So we know the locus of B in the front view also, and you know the locus of B in the top view. So this is how this the initial step of your drawing. How to solve this? How to draw this by using the orthographic view. First we are going to draw the XY line and you mark VP and HP. So the point A is on VP. VP means on HP. So you're going to get A. Then above HP is seen in VP. So you're going to get A dash and you mark this point as capital A. And you mark this point also as capital A in the top view. Then the top view of the line is inclined at 30 degrees to VP and it has got 80 mm length. So he has given the beta inclination. So with by using the protractor with A center with respect to the XY line, you measure an angle of 30 degrees in the clockwise direction and then mark that point, then draw a line passing through that point. Then by using the compass with A center, taking the radius of 80, cut an arc on this 30 degree line. So you mark this point as B, then draw a horizontal dashed dot line. So then you write the locus of B in the top view. And here join between A and B with a dark line. So because this is the top view line. So this is how you will be able to write the initial position of the drawing. That is basically because whatever the data which is given in the problem, I have taken the entire thing and I have been drawn this. Now what I need to do? So as we know we have the top view, and you know the locus of B in the front view and you have also know the locus of B in the top view. So since you know the top view point, so obviously the front view point should lie on the same line. So draw a vertical projector from this to the XY line because point B is on HP. So obviously that point can be seen in the vertical plane. So you mark this point as B dash and then join between A dash, B dash. So this will going to become the front view and this will going to become the top view. So A is on VP and B is on HP. So now you have got a line from A dash to B. That is, this is the one which we are going to talk about, which is the line in space. So then how to do that? By using the manual drawing. So here with B as center, so now what I know, since you know the locus of B in the front view and also the locus of B in the top view, so we have the end projector A. And we know that this is the top view point, so obviously that front view point should lie on the same line. So since you have the locus of B in the front view, so draw a vertical projector from B to the xy line in the front view, and you mark this point as B dash. Then join A dash B dash with a dark line. So you have the front view and you have the top view. Now what I need to do, I need to find out the true length in the front view and also the true length in the top view. So how to do that? So I want to find out the true length in the front view. So if you want to find the true length in the front view, I should make a line, the top view line parallel to xy. So which is the top view line? This is the top view line what I have. So this is the line in space with this as center. By holding the line at this point and rotating the point B such that both A and B are in front of VP by same distance. Why? Because I need to find the true length in the vertical plane. Since I want to find out the true length in the vertical plane, obviously that should be parallel to VP. So A is on VP, so B should also on VP, then only the line will going to become parallel. With A dash as center, taking the radius of AB, you draw an arc such that both B1 and A will going to lie on the same line. This is the one method. If you want to take it in the space, this is the line which is in space with this as center, taking the radius of this, and you are rotating that such that this B will going to lie on the vertical plane. Now the line is parallel to xy in the top view. Since the line is parallel to xy in the top view, obviously in the front view that line will be in true line. How do I know that that will be in the true line? You have B1, A is in VP, B1 is also on VP, so AB1 is parallel to VP. So since it is parallel to VP, so you are getting the true length in VP. So what is the front view point of AB1? The front view point of AB1 is A dash B1 dash. A is here, so A dash will be above HP, and B1 is here. The point B1 dash is the locus of B, whereas B1 dash is on B. That is the other end point of B is on the locus of is on VP. Since it is the other end of B is on VP, so obviously that point will going to be the line which is in the true length. So here you can see here the other end point of the B. The point B is on the horizontal plane. Since the point B is on the horizontal plane, so that will be on point B is on the horizontal plane. Naturally, that will be image can be seen in the vertical plane. So A dash B1 dash is the line which is in true length because its corresponding top view. A is on VP, so B1 should also be on VP. But B1 is already on HP, therefore the point B1 is on both HP and VP. Since it is on HP, the image is seen in VP, that is B1 dash. Since it is on VP, the image is seen in HP, so it is B1. So now the point is on both HP and VP, therefore A dash B1 dash will going to be in the true length. So that is the reason why I have capital A and I have capital B here. So the inclination made by the true length with respect to HP is theta. So you mark that. Now the next thing is how to draw this by using, now how to draw it manually. So now I want to find out the front view in true length. Since I want to find out the front view in true length, obviously the top view line should be parallel to HY. Which is the top view line? AB is the top view line. A is on VP. Since A is on VP, so B should also be on VP only. With A as center taking the radius of AB, you draw an arc such that B will going to come and touches the XY line in the top view. So therefore, AB1 is the line which is parallel to XY line in the top view. But B1 dash is also already on HP. So since it is on HP, so the point will going to be the locus of B in the front view. So this B1 dash, A is on VP, so B1 is also on VP. But B1 is also on HP, therefore B1 dash will also be there at that particular point. Now the point, it is the case of point is on both HP and VP. If it is on HP, it will be seen in VP. If it is on VP, then it will be seen on HP. So this is how you will be able to get this point B1 dash. Then join A dash B1 dash with little bit thicker than the XY line. So since the line top view line AB1 is parallel to XY, the corresponding front view A dash B1 dash will be in true length. Since it is the true length line, therefore you mark this as capital A and you mark this as capital B. So that is what we have shown here. So this is the line which is in space. You are rotating such that both A, that is this point, and also the other end point of this will going to lie on the same plane, that is on the vertical plane. So this is how you will be able to get the line parallel to VP. Now the next thing is you can measure the angle true inclination with respect to HP, which is theta. Now the next thing is I want to find out the true length in HP. So if you want to find the true length in HP, obviously that line should be parallel to HP. So how to get that? So here A dash is above HP by 40 mm, but B is not above HP by 40 mm because now the B is on HP. Since B is on HP, so obviously that point will be on VP. So that is what we have got here. Now actually this the point A is on VP. So the point B, this is the locus of B in the top view. This distance is in front of VP by some distance. But what I want to find out the true length in HP. If you want to find the true length in HP, obviously that line should be parallel to HP. So this is the one which we are talking about, which is capital A and capital B2. So how I should be able to get this? With A center, you taking the radius of this, which is in space, you rotate this endpoint B here, such that both this point and this point will be parallel to HP. Since it is parallel to HP, so you are getting the true length in HP. So how to do that now? So when you are rotating this, what happens here in space? Both capital A and B2 are above HP by 40 mm, but you have certain inclination which is equal to phi. But now, how exactly as we rotate this, how exactly that will going to behave in the vertical plane? By looking from the front view with A dash as center, taking the radius of A dash B dash, you are rotating this such that both A dash and B2 dash will be above HP by same distance, which is 40. So both A dash and B2 dash will be parallel to HP. Since it is parallel to XY line, then its corresponding front view, which is that this is the corresponding top view, will be in true length. So this point, the AB2 is the line which is in true length. So you make A dash, capital A and B2 is made parallel to HP. Therefore, you are getting the true length in HP. So once you get this point, you will be, what happens to that point? That point will going to be here with A dash as center. So as we are rotating this, what happens in the image also in the vertical plane? So image is also in the vertical plane is being getting rotated. So as we see from the front view, so this point will going to be on VP, above HP and on VP here. Since it is on VP, so obviously that point will be on HP. Now here B is on HP, so obviously that point will be seen in the vertical plane on the XY line. With A dash as center, as we are rotating this in space, then what happens to that image in the vertical plane? Image in the vertical plane is also getting rotated such that both A dash and B2 dash are above HP by 40. That is, A dash B2 dash is parallel to XY line in the front view. Obviously, in the top view, that line will be in true length. So you get that B2 which has got capital B and you have capital A. So you know that this is the true length in HP because this line is parallel to HP in the front view. So that can be seen only in the front view. Parallel to HP I cannot see from the top view, and parallel to VP I cannot see from the front view. So this is how you will be able to analyze this drawing in 3 dimension. Now how to do that? By you considering in the 2 dimension. So I want to find the true length in the horizontal plane. Since I want to find out the true length in the horizontal plane, that is the top view, I have to take the front view line with A dash as center, taking the radius of A dash B dash. You draw an arc such that B2 dash is also above HP by 40 mm. So A dash B2 dash is the line which is parallel to XY in the front view. Obviously in the corresponding top view will be in true length. Here A is there, B2 dash should be projecting to the locus of B in the top view. So you mark this point as B2. As we know that this is the parallel to XY line in the front view, obviously this line will be in true length. So you mark this point as capital A and you mark this as capital B. So join between A and B2 with little bit thicker than the XY line. So then you need to measure the true length of the line. Either true length is same either in the front view or in the top view. You can measure this length, that is A dash B1 dash, or you can measure AB2. So both will going to have the same length. The true length of the line will be 89.44 mm, and then the true inclination with respect to HP is 26.57 degrees, which is 27 degree, and the true length with respect to VP, or the true inclination with respect to VP, which is 5, will going to be also 26.57 degrees. When you are doing it in manual, when you are doing it in computer, true length will be 89 or 90, theta will be equal to 27 degree, and phi will also be equal to 27 degrees. So this is how you will be able to analyze the drawing and do it on manually by using the sketchbook. Show the dimensions of this true length which is to be found out. So you show the dimension of 80, then you have 30, and it is 40 mm above HP. How do I know that my problem is right? Why to analyze it finally? So you can see here, this is the top view line AB because its front view is inclined. You know this is the front view because its corresponding top view is inclined. You know that this is the true length in HP, so that means in the top view it is the true length, therefore its corresponding front view A dash B2 dash. What happens? Where is A dash? A dash is here, B2 dash is here. So it becomes parallel to HP. Since it is parallel to HP, we are getting the true length in HP. But in other words, this is the top view true length. So obviously this line will be the parallel to XY in the front view. You know this is the front view true length. That means its corresponding top view, which is AB1, is parallel to XY in the top view. So this is how you will be able to analyze the drawing in 3D dimension, and you can do it manually by using the sketchbook. So this is how you will be able to write the drawing. Thank you.